Hi, good morning everyone. I am Kunjithapadam Sivakumar, Associate Director, Data Science Team from Crunchmetrics. So today we'll be looking into anomaly definition and its representations. So what is an anomaly? Anomaly is anything which does not fit in a particular pattern, right? So the pattern could be either which could be a user defined, or it could be something which is learned from the historical data. Now when you talk about data, so we could have like two different type of data. One is time series data, other one is a cross-sectional data. Now let's say there is a traffic data flow from a mobile network tower. Right. Now we could observe that it gradually decreases in the night and it peaks out in the morning. So you could see the cyclic variations in the data. Now this is an example of a time series data. Now in other example, say if you are tracking sales of a particular product. Now that need not be necessarily a function of time. It could be function of the discount given. It could be function of the price changes, or it could be the function of the stock units which are kept. So these kind of data is referred as a cross-sectional data. Now let's come to the different type of anomalies. So what are point anomalies? So point anomalies are any surge or sudden dip observed in one particular instance. These are also called as global anomalies. Say for example, there is a overall there is a dip in the booking. That's an example for a point anomalies. So contextual and collective anomalies. So the threshold value to define something as anomalous, it's always depend on particular context. Now the context could be the time itself, or the context could be some sort of other hierarchies in the data set, or like say regions or states, that kind of situations. And the collective anomalies are like those group of matrices which when observed together represent an anomaly, but they may or may not have anomalies when they are observed individually. Now let's say if we have detected these anomalies, now it's equivalently important to represent these anomalies in a way that business will be able to convert these observations of anomalies to an actionable insight, right? So what are the different ways that we could represent? So the first one is continuous or near continuous anomalies. So as the name suggests, so this is an example where we are having anomalies occurring repeatedly for n data points, correct? So for example, we are having a continuous dip in the orders which are booked. So now for a operation team who are monitoring these anomalies, so observing this kind of continuous anomalies will help them to prioritize their task, and they will know for sure that there is something wrong, and until it is fixed, the anomaly is going to persist, correct? The other one is the near continuous anomalies. So near continuous is very similar to continuous anomalies, but except that within a given time frame there are anomalies, but they are not continuous in nature, but majority of the data points are actually anomalies. So that kind of insight also will help the business to take some proactive actions. The other one is the missing data point anomalies. Say for example, from Android platform, so we are observing some missing data points. Now there are two ways of representing it. Say the first way, say we could say that there is some anomaly in the Android platform. The second way of putting is there is no booking coming from Android platform, right? So the second way of representing is actually more impactful. So it's always necessary to represent the missing data point from your regular anomalies. The third one is anomalies with hierarchical association. So in any business, we could observe like two different type of hierarchies, right? For example, I could do the booking through different platforms like Android or iOS, and also I could do the booking either as a signed in user or as a guest user. Now if you see these two entities, the platform and the signed in user, there are two different entities, and we could have a many-to-many relationships, right? Now, but still the business would be interested to first see, okay, how many bookings are happening through my Android? If there is any dip in that, then I would like to see if the dip is coming from the signed in users or from my guest users. This is one type of hierarchy. The other type of hierarchy is, say suppose I'm a regional manager for a delivery unit for an e-commerce platform, and I'm controlling one particular city. That city is having multiple regions. Each region is having multiple zones, and each zone is having multiple delivery units. Now if there is any dip or like say increase in the SLA breaches for that city, I'd like to drill down and see which region or zone or delivery units are actually contributing to this. So that's a different type of hierarchical association. The final one is association and correlation of anomalies in different KPIs. Now we could have different scenarios and examples for this. One of the basic way of putting this one, or as a basic example, is say suppose if I'm a telecom network carrier, I'm interested to understand if there is any artificial inflation of traffic in my network. To understand that, I would like to observe if there is any surge in the number of calls, and at the same time, if the average duration of the call goes down, then that will give me an insight that that probably there is some sort of an automated system which is triggering these kind of short duration calls. So these are the different type of anomalies and the representations. So that's all we have for today. Thanks a lot for watching. Thank you very much.